What is a stream function? So a stream function is defined in such a way that u, that is velocity in x direction, is equal to minus dou psi by dou y. Here psi is your stream function and v is equal to dou psi by dou x. So stream function is defined in such a way that u will be equal to minus dou psi by dou y and v is equal to dou psi by dou x. This is applicable only for a two-dimensional fluid flow. So for a streamline, psi will be a constant. Stream function will be a constant. For example, let us draw a streamline. So these are the various streamlines. So for each streamline, psi will be a constant. Here psi is equal to C2, here psi is equal to C3. And you know that a streamline is defined in such a way that tangent to this line will give you the velocity at this point. So for a streamline, stream function is a constant. Okay. Now let us draw another streamline. You can see that for this streamline is defined such that tangent to the streamline will give you the velocity as we have discussed earlier. And this velocity has got two components, that is x component and y component. That is x component is the velocity u and y component is v. And you can see that this v is equal to minus dou psi by dou x and u is equal to dou psi by dou y. Now let us see what is a potential function. See, potential function is defined similar to stream function but in such a way that u is equal to minus dou phi by dou x and v is equal to minus dou phi by dou y. So for a potential line, for an equipotential line, phi will be constant. That is, potential function will be constant. Now let us see stream function and potential function and also flow net. So you can see a pipe flow here and you can see several lines like for phi is psi is equal to C1, C2 and C3. So these are streamlines. Okay, you can see the streamlines and also you can see the potential lines. These are perpendicular to the streamlines. So this is phi is equal to d1, d2, etc. So these are potential lines. For phi is equal to d1 and phi is equal to d2, phi is equal to d3, like that. It goes on like this. You can see that these streamline and potential line intersect each other at 90 degrees. So let us write a differential potential function, that is d phi is equal to dou phi by dou x into dx. So it is delta x and this is delta y. So you can see that this see, if you take the limit it will become dx. So dou phi by dou x, as we have defined earlier, it is equal to minus u and dou phi by dou y is equal to minus v. So for equipotential line, d phi will be 0. That means for a line in which potential function is constant, d phi will be 0. So dy by dx will be, for that line, dy by dx will be equal to that is for phi is equal to constant, this is equal to minus u by v. See, dy by dx means that is the slope of the tangent. So that is equal to minus u by v. Slope of the tangent in the stream equipotential line. And now let us see a streamline. For a streamline, stream function is constant, and you can write d psi is equal to dou psi by dou x into dx delta x plus dou psi by dou y into dy. This is equal to 0. So if you substitute the equation, that is dou psi by dou x is equal to v according to the definition, and dou psi by dou y is equal to minus u. For this you can see dy by dx, for that is psi is equal to constant, this is equal to v by u. So dy by dx is the slope of the tangent to the streamline. If you draw a streamline and this is the tangent, so this theta, tan theta will be dy by dx, so that is equal to v by u. So you have found out the slope of the tangent for both a streamline and an equipotential line. So if you multiply both of these, dy by dx for an equipotential line and dy by dx for a streamline, you will get minus u by v into v by u, that is equal to minus u. This indicates that these two lines intersect each other. That means these two tangent lines intersect perpendicular to each other. Now let us see how to find the rotational velocity of a fluid. See, rotational velocity is defined such that omega z is equal to half into dou v by dou x minus dou u by dou y. That means for a fluid flow, see, for a fluid flow like this, if you put a plate here, if the top velocity is higher than the bottom velocity, so the top layer flows at a higher speed than the lower layer, so that means the velocity is different at both these points. This can cause the plate to rotate in the clockwise direction. So this causes a rotational flow. So this can happen in the y direction also. That means the velocity variation in the x direction. So this is due to the velocity variation in the y direction. This can also occur to the velocity variation in the x direction also. So this velocity variation is mainly represented by dou u. This is caused by dou u by dou y. This causes a clockwise rotation. So similarly, dou v by dou x also causes a rotational velocity. So the correct formula which which gives you the velocity or the rotational velocity in z direction is equal to half into dou v by dou x minus dou u by dou y. Similarly, the rotational velocity in x direction is given by half into dou w by dou y minus dou v by dou z, and omega y is equal to half into dou u by dou z minus dou w by dou x. So, what is vorticity? Vorticity is just the twice that of the angular velocity. Omega z, omega x, and omega y. This is just twice the angular velocity. So now let us derive the Laplace equation for a stream function. You know that for a two-dimensional flow, the continuity equation states that dou u by dou x plus dou v by dou y is equal to 0. And also you know that for a stream function, we define a stream function in such a way that u is equal to minus dou psi by dou y and v is equal to dou psi by dou x. So if you substitute u and v here in this equation, you will get dou by dou x into minus dou psi by dou y plus dou by dou y into dou psi by dou x is equal to 0. So that is equal to dou square psi by dou x dou y plus dou square psi by dou y dou x. So mathematically, dou square psi by dou x dou y is equal to dou square psi by dou y dou x. So that means the existence of this stream function means that continuity equation is obeyed. That means simple existence of stream function indicate a possible case of fluid flow. Possible case of fluid flow. And you know that the angular velocity is equal to half into dou v by dou x minus dou u by dou y. If you substitute v and u from these two equations, again you will get omega z is equal to half into dou by dou x into dou psi by dou x minus dou by dou y into minus dou psi by dou y. This is equal to half into dou square psi by dou square x plus dou square psi by dou square y. And if this is equal to 0, if dou square psi by dou x square plus dou square psi by dou square y is equal to 0, that means this is a case of irrotational flow. And this is the Laplace equation. So if psi obeys Laplace equation, that means it is an irrotational flow. And if stream function psi exists, that means it is a case of possible steady fluid flow. Now let us see potential function in applied in a Laplace equation. So you know that for a two-dimensional steady flow, dou u by dou x plus dou v by dou y is equal to 0. Two-dimensional continuity equation. And you know that u is equal to minus dou psi by dou x and v is equal to minus dou phi by dou y. This is by definition. So you can see that dou square phi by dou square x plus dou square phi by dou square y is equal to 0. If you substitute u and v in this equation, that means dou by dou x into minus dou phi by dou x plus dou by dou y into minus dou phi by dou y. So is equal to 0. So that is dou square phi by dou x square plus dou square phi by dou y square is equal to 0. So the potential function satisfies Laplace equation, then this is a possible case of steady flow. Then only it will obey, continuity equation is obeyed. So existence of phi does not mean it is a possible case of steady flow. Only if phi obeys this Laplace equation, satisfies the Laplace equation, then only we can say that it is a possible case of steady fluid flow. So now let us see the angular velocity. Angular velocity is defined as omega z is equal to half into dou v by dou x minus dou u by dou y. So if you substitute v and u from here, you will get this is half into dou by dou y into dou phi by dou x. So actually it is minus dou phi by dou x. You will get here, it will be minus and it is plus here, minus dou square phi by dou x dou y plus dou square phi by dou y dou x. Mathematically, dou square phi by dou x dou y is equal to dou square phi by dou y dou x. So that means this will naturally tend to 0. So that means the existence of phi means that it is a irrotational flow. But existence of phi does not mean that it is a possible case of flow. So these two are important. That is, existence of phi, psi means it is a possible case of steady fluid flow. If psi obeys Laplace equation, that means it is irrotational. If phi obeys Laplace equation, it is a possible case of steady fluid flow. But existence of phi simply means that it is a irrotational